All right, let's look at our next concept, which is expected value. The expected value of some variable might be the number of children in a family, the number of times it takes to roll a dice and land on a 6, right? They're variables, discrete, random variables. The expected value is kind of like the average of that variable. So if you were to play, that game of rolling a dice and trying to land on a 6 over a long period of time, the expected value would give you the value that you'd expect to get on average over a period of time. And we can use this formula here in pink to calculate the expected value of a discrete random variable. So the expected value, which we give a symbol, sigma, or the expected value of our variable, is equal to the sum of all values of x multiplied by the probability of each of those x's or values. So basically what you do is, if you've been given a probability distribution, is you just grab your values, you multiply them by their probabilities, just ignore that, and you do that with each of your values, and then you just add them together. That's pretty much what you do, okay? So this is a real, dry example. There's no story behind this one. Let's just go ahead and calculate the expected value given this particular probability distribution. So go ahead and write a sigma, or our expected value, just using all the notation, is equal to the sum of all values of x multiplied by the probability of each of those values. So in this case, it'll look like this. I'm just going to quickly change these values because I already have an example that I'm working with. It doesn't change anything that I've said previously. I'm just changing this. All right. So in this case, it would be 0 times, the probability associated with that 0 value, which is 0.064. Okay. We're going to add that to the next value. So 1 times 0.288 plus 2 times 0.432 plus 3 times 0.216. Chuck all of that in a calculator. The expected value of this probability distribution, or of this random variable x, is 1.8.